A few months ago, physicists in Vienna took a solid piece of metal and put it in two places at the same time. Not an electron, not a photon. A lump of metal up to 10,000 atoms, heavier than most of the proteins inside your body right now. And here's why that should stop you mid-scroll. This experiment wasn't built to show off a magic trick. It was built to find the edge of reality, the line where the quantum world ends and your world begins. By the end of this video, you'll understand exactly what they did, why it just broke a world record by a factor of 10, and the part almost nobody covering this story is saying out loud what it means that they went looking for the boundary of reality, and it wasn't there. Because the deeper you follow this one, the more it starts asking a question physics can't answer alone. If matter doesn't choose a single reality on its own, what holds the world together in one piece? Quick foundation, 60 seconds, because everything that follows depends on it. Quantum mechanics says that matter at the smallest scale doesn't behave like little marbles. It behaves like waves. An electron isn't sitting in one spot. It's smeared across space as a wave of possibilities, and it only shows up in one place when it interacts with the world, when it's measured. Scientists have confirmed this over and over. Electrons, atoms, small molecules. Fire them through slits, and instead of landing like bullets, they land like waves, interference stripes, the fingerprint of something that traveled multiple paths at the same time. But here's the 100-year-old problem. Look around your room. Your coffee cup is not a wave. Your phone is in exactly one place. Somewhere between an atom and an apple, the quantum weirdness disappears. And for a century, physicists have asked, where is that line? Is there a size where the universe forces matter to pick one reality? Erwin Schrödinger made this famous with his cat. The thought experiment where a cat is both alive and dead until observed. Everyone knows the meme. Almost nobody knows that in 2026, a lab in Vienna essentially ran the experiment for real, not with a cat, with metal. Here's the experiment, and I'm pulling this straight from the paper in Nature. The journal, not a blog. Researchers at the University of Vienna, led by Markus Arndt and Stefan Gerlich, working with theorist Klaus Hornberger in Germany, created ultra-cold clusters of sodium metal, real solid metal particles, each made of 5 to 10,000 atoms. Each cluster is about 8 nanometers across. That's roughly the size of a transistor in a modern chip. Each one weighs more than 170,000 atomic mass units, heavier than most of the proteins running your cells. Then they launched these metal particles through 3 gratings made of ultraviolet laser light. The first laser pins down each particle's position and pushes it into superposition, the state where it genuinely follows multiple paths through the machine at once. And then comes the moment of truth. If the metal behaves like a classical object, like a marble, the particles land in a smooth, boring blob. If it's still quantum, you get stripes, interference, the signature of one object that traveled more than one path. They got stripes. Each piece of metal existed spread across locations separated by more than 10 times its own width. The lead author Sebastian Pedalino said it plainly. You'd intuitively expect a lump of metal this large to behave like a classical particle. It didn't. The metal was a whole in the team's own words, here and not here at the same time. Now here's the part most of the coverage gets wrong, and it's the actual story. Everyone's reporting this like a stunt. Haha, metal in 2 places, physics is weird. No, flip it around. This experiment was not designed to demonstrate quantum mechanics. It was designed to catch it failing. See, there's a whole family of serious theories. They're called collapse models that say the wave function doesn't just describe reality, it physically snaps into one outcome on its own once an object gets big enough. No observer needed. Reality self-collapses above a certain size. If any of those models are right, then somewhere on the ladder from atoms to apples, the stripes have to vanish. So physicists invented a brutal scoring system for these tests. It's called macroscopicity, literally a number measuring how hard your experiment squeezed the limits of quantum theory. Before this, the world record was held, fittingly, by giant tailor-made molecules tested in this same Vienna lab, sitting about a full point lower on the scale. The new experiment hit 15.5. And because the scale is logarithmic, that's roughly 10 times beyond anything ever done anywhere on Earth. And to make that number land, listen to this. To run an equally strict test of quantum mechanics using electrons, you would need to hold a single electron in superposition for about 100 million years. The Vienna team matched that level of scrutiny with a chunk of metal in 1/100th of a second. They gave reality 10 times more room to act normal. It refused. So here's the punchline, and it's the existential one. Every time physicists build a bigger, cleaner, more hostile test, the boundary between the quantum world and the everyday world fails to appear. Photons, quantum, atoms, quantum, molecules, quantum. And now, a solid piece of metal you could almost call an object, heavier than most proteins, still quantum. The Vienna results didn't just set a record. They tightened the noose on every model that says reality collapses by itself. Petalino's exact point. Quantum mechanics holds at this scale and does not require alternative models. The collapse theories aren't dead, but the room they have left to hide in just shrank by an order of magnitude. And the team has already said the next phase is bigger particles, new materials, pushing this several more orders of magnitude, which means we are now living through the decade where humanity finds out, experimentally, not philosophically, whether there is any size at which the universe forces matter to choose one reality. And so far, the answer keeps coming back. There is no edge. The wave never chooses on its own. Something else resolves it. Now let me be careful here. The way I always try to be, what I'm about to say is meaning, not measurement. Hold it loosely, watch closely, the science stands on its own. But you cannot sit with this result and not feel the question underneath it. If matter, left alone, stays suspended in possibility, if a piece of solid metal doesn't occupy one definite place until it interacts, until it's registered, then the solid, single, dependable world you woke up in this morning is not the default state of matter. It is being resolved continuously everywhere. 2,000 years ago, Paul wrote in Colossians that in him all things hold together. Hebrews says the visible world was not made out of what was visible. For most of history, those read as poetry. And then physics spent 100 years discovering that the visible, definite world really does sit on top of an invisible layer of unresolved possibility. And that the definiteness, the togetherness, is the thing that needs explaining. I'm not telling you this experiment proves God. It doesn't, and anyone who says a lab result settles that question in either direction is selling something. What I am telling you is that the most rigorous test of reality ever performed just made the materialist's easiest answer. Things are just solidly there. End of story. Harder to defend than it has ever been. We're not closing the question with a microscope, but we are opening the conversation again. And before anyone files this under cool but useless, the machine that did this is also one of the most sensitive force sensors ever built. The Vienna interferometer can detect forces down to 10 to the minus 26th newtons. That opens the door to reading the electrical, magnetic, and optical properties of single nanoparticles, and it sits in the same matter wave technology lane that's being developed for navigation that doesn't need GPS, and ultimately tabletop experiments sensitive enough to test whether gravity itself is quantum. The same wave nature of matter that raises the deepest question humans can ask is about to become an instrument. That's the pattern of every quantum technology so far. First, it breaks your worldview, then it ships in a product. So if you remember nothing else from this video, remember this. Scientists built an experiment designed to find the edge of reality, the place where the quantum world ends and your world begins, gave it 10 times more room than ever before. And the edge wasn't there. Matter doesn't choose one reality on its own. Something resolves it. And the next few years of bigger, heavier experiments are going to push that question further than any generation in history has been able to take it. I cover what those experiments find and what they mean for both your worldview and your future every single week, the moment they drop. Subscribe so you're here when the Vienna team runs the next rung of the ladder, because I'll break it down the day it publishes. What do you think resolves the wave? Drop it in the comments. I read everyone, and the best answers shape the follow-up video.